And here we go. Section 2 of Chapter 6, we're going to look at the forest biomes. Now, Cornell Note-wise, this is broken down into a and a B section. I'm going to push all through it in one video, but it's going to be 2 sets of Cornell Notes. So don't cram this all together if you're watching it. Doing Section A today, be a couple of days after a lab before we get to Section 2. If you want to knock it all out at once, that's okay. But 2 essential questions, 2 sets of Cornell Notes, 2 summaries, the whole 9 yards. All right, here we go. So we're going to look at forest biomes, your essential question. I want you to name and describe the main layers of the tropical rainforest. Name and describe, be able to go through them. When we talk about forest biomes, our first key term right off the top. Of all the biomes in the world, the forest biomes are the most widespread and the most diverse. We find them in every continent, in every kind of section, latitude, you name it. Now, large trees of the forest need a lot of water. So we find forests where the temperatures are mild to hot, and there is a lot of rainfall, or at least precipitation. It could be snow as long as it's melting. But we have to have a lot of precipitation in order to have a forest. Large organisms need lots of water. 3 main forest biomes: tropical, temperate, and coniferous. Basically tropics, between 0 and 30, temperate between 30 and 60, and the coniferous, they're either high up in altitude or they're high up in latitude. They tend to be in these cold areas. So we tend to find coniferous forests above the 60 latitude line. We're going to start talking about tropical rainforests. Tropical rainforests are our most biologically diverse, and they're going to take up most of our time for this section A. Tropical rainforests. These are forest or jungles near the equator. Once again, tropical. Characterized by large amounts of rain and very little variation in temperature. Stays a similar temperature year round. Always hot, always humid. They also contain the greatest amount of diversity. Something like 50% of all known species exist in the rainforest, even though they only take up about 7% of the landmass. Very small percentage, but a huge amount of diversity. Also, rainforests help to regulate the world climate. They play a very vital role when it comes to the nitrogen cycle, the oxygen cycle, carbon cycle, even the water cycle. Because there's so much rain there, they're temperate, they keep it humid. So they're a very important process for the 4 main cycles on the planet: water, carbon, nitrogen, oxygen regulation. Very, very important. Humid, warm, and they get a lot of sunlight. Guys, when it comes down to it, sunlight, water, and temperature, these are the big 3. If you're a land-based organism, those are the 3 main factors that you need. The tropics have all of it in abundance. They maintain a fairly constant hot temperature, and this is an ideal combination for both plants and animals. By and large, the climate dictates what kind of plants can grow there. The types of plants bring in the various animals. A lot of diversity of plants, a lot of diversity of animals. The picture that we have up here is kind of the chart. It can be a little hard to see from there, but these are the tropical rainforests. We find some in Central America, South America, in Africa, also going over into Asia. A tiny bit of India, but large swaths of Thailand, Vietnam, Indonesia. This whole area is rainforest. So kind of the one largest stretch is there in South America, the Amazon, but we can see this swath where they're found. Once again, between 0 and 30. And realistically, we actually find them between about 0 and 20. That's the true tropics. 20 to 30 is more like subtropical. And you kind of see the chart of the rain. It stays fairly constant. We kind of have a dip there somewhere around September. But overall, as we look at the other charts and graphs, we'll see that their rainfall is much more, it's higher and much more consistent than our other areas. Now let's talk about nutrients. Nutrients in the tropical rainforest. The nutrients are up in the plants, not the soil. This is unique. If it's unique, you want to remember it. It's going to show up in test questions here, there, and yonder. So, rainforest, bad soil. All the nutrients are up in the plants and in the trees. A lot of these trees support various fungi, and the fungi are feeding on the dead organic matter that's on the rainforest floor. So they're on the trees or around, and their tendrils are dipping down into the floor, and they are sucking the nutrients literally out of the ground directly into the tree. The tree's getting a symbiotic relationship here with some, not all, but some of the types of fungi. That they're literally pulling nutrients out. Part of it's going into the tree, part of it's going into these specific fungi. It tends to be very shady on the forest floor. Perfect environment for fungi, our decomposers of the plant world. Bacteria for the animals, fungi tend to be the decomposers of the plant world. Lots of different varieties that we see. The nutrients from the dead organic matter are removed so efficiently that the runoff from the rainwater tends to be about clear, distilled water. So the rain comes down, it comes through the trees, hits into the ground. The things are sucking all the various nutrients, any kind of pollutants that are in the water. By the time the water makes it out of an area of rainforest, it's just pure distilled water. Everything has been taken out of it. Everything is sucked up into the plants. Because of this, most of our tropical forest or our rainforests that we clear out to try and grow plants really lack the nutrients, and they can't support crops for more than a few years. So when you see places where they're clearing out the rainforest to plant crops, they can't do it very long. It's really bad soil. So they clear out the trees, they plant crops. After a few years, they can't grow any more crops. They go to a new section of the forest, cut it down, start it again. And a lot of this forest just gets turned into kind of rangeland or pasture land. It's not much good for anything else. And it's really hard to reclaim it for forest once we've deforested it, cut it down. A lot of the trees form these kind of above ground roots. Once again, the soil's not that great. There's not enough nutrients in it, and they don't tend to build these really deep roots because it keeps raining all the time. The rain's up near the surface. So a lot of them build these kind of buttresses or braces, as you can see in the picture here, with a person standing, if you could make the person out. These buttresses can be like 5, 6 feet tall, these massive trees, and those buttresses are providing the structure. In architecture, we talk about flying buttresses up in the ceilings that give the building support. Well, these are buttresses down on the ground, and this is what gives the tree stability in winds and storms, etc. Because the soil is poor and very thin, so they have to kind of build up instead of what we're accustomed to here in the deciduous forest with them kind of growing down. When we talk about the rainforest, it comes in layers. Every forest has layers, every area. But the rainforest has 4 specifically that we will talk about. And right now I'm going to talk about it from the top down, if you will. 4 main layers. The top is the emergent layer. These are the trees that emerge out of the general canopy. So you see this whole, and then there's this big tree and this big tree over here. If you ever saw the movie Avatar, you get the idea, that big tree that pops way out up. We get those in our rainforest. Then we have the upper canopy. This is the main branch of all the trees. We have what we just refer to as the lower layer. This is kind of below the tree level, but prior to getting to the ground. We have a lot of things in this lower level of the trees, kind of below the main leaf line, if you will. And then the very bottom layer, right down on the ground, is the understory. Make sure you can identify these different layers and know what we tend to find where. We're going to break these down in a little more detail as we go. Well, let's start with that emergent layer, this tippy top layer of the trees popping way out from the canopy. Top foliage, these trees in this layer emerge and they have very direct sunlight. These things can reach heights of 60 to 70 meters. We're talking football field size in height. They are massive. Not 60 to 70 feet, meters. These things can be as big as 5 meters around. So you want to talk about being a tree hugger? It's really difficult with these guys. You got to get 5 or 6 of us together to get all the way around. Massive trees. Now, what we find in the very top of these trees are certain organisms and animals. Things like eagles, bats, monkeys, and snakes. In the rainforest, everything's up in the trees, including the snakes. You and I say, ooh, look, a snake, and we're looking on the ground. In the rainforest, there's a snake. You gotta look up. But these guys find their home way up in these tippy top branches. It keeps them out of competition of everything in the other layers. We're going to find we get these kind of various layers of things that we find there. Now, when we talk about monkeys and bats and etc., there are all kinds. There's little teeny tiny monkeys the size of a finger. We get chimpanzees, full-size apes. We have the Reese monkeys. Same with bats, come in all shapes and sizes. Whether it's fruit bats, these guys can get really big, down to blood-sucking bats, etc., and they tend to be smaller, kind of creep up on their prey to draw blood, if you will. And taking us to the canopy. So the emergent layer, that kind of tippy top things poking out. The canopy is this treetop layer. And this is really the main layer of the rainforest. These provide shade to the forest floor. Now these trees are somewhere up in the 30 meters tall, but not 60, 70, 30 meters tall or so. These are going to be the range of our oak trees that we find around here. Oak, sycamore, etc., getting into this size range. But they form that, once again, really dense layer. They absorb up to about 95% of all the sunlight. The emergent is getting full sun all the time. This layer, the very tops of the trees are getting sun, but below it, very little sunlight is reaching the forest floor. It's all blocked out by this big canopy. And we can talk about the canopy in the upper canopy, and this is what you and I think of really as the leaf line, where all the leaves are in the tree. So that's the upper canopy, and then we have the lower canopy that's getting much less light. That's going to be right at the bottom of the leaf line and into part of the trunk of the tree, like where the big branches are coming off. This is where we're going to find that lower part. So we have emergent canopy, canopies in 2 layers, upper canopy and a lower canopy. Now what we find in this lower canopy a lot of times are epiphytes. You've heard of the word parasite, something that attaches to something else and takes its nutrients from it. An epiphyte is a plant that uses another plant for support, but not for nourishment. And they tend to be located high up in the trees, on the branches, on the trunk. Orchids are some of the classic ones that we talk about. But here in Florida, we have a lot as well. We have orchids here in Florida, the famous ghost orchid down in the swamps below us here in Gainesville, but also the Spanish moss. This is an epiphyte. We have bromeliads as well. Anything that's hanging on the tree, but it's not taking nutrients from the tree. This is an epiphyte, uses it for support. We talk about these relationships in another chapter, and this is a commensalist relationship. The Spanish moss gets a benefit, the tree doesn't care. The same with the orchid. The orchid gets a benefit, somewhere to be, stationary and has, but the tree doesn't care. Commensalist relationship. They grow on the trees. It allows them to get high enough up to get photosynthesis. We still have some light filtering through at this point. And then they absorb water and the nutrients as it runs down the trees. As things die and decay and the water runs down, they're absorbing nutrients right off of the tree, not from the tree. Things that are dead, dying, and decaying, ants, whatever have you, as that runs down, this is where they're getting their nutrients. Epiphytes, remember that word. And most animals that live in the rainforest actually live up here in the canopy, either the lower or the upper canopy. This is housing most of the organisms there because this is where the fruit and the flowers are. This is where most of the food, if you will, exists. So this is where we find most of our organisms. The understory is this foliage layer. It's beneath and it's shaded by the canopy, the forest floor, if you will. Very little light reaches this layer, so only trees and shrubs that are adapted to the shade grow there, like ferns. Ferns are a classic example of what we expect to find in this understory. But there are other types of trees, types of bushes, but they have to be adapted for very little light, and most things don't grow more than a few meters tall. Now, a few meters tall is still I'm like not quite 2 meters tall. There's still plants taller than I am, but incredibly small compared to a 70-meter emergent tree or a 30-meter tree. Still low-lying growth down on the forest floor. And this takes us to some of our species diversity. The diversity of a rainforest has led to the evolution of just a diverse community of various animals there. Most of these rainforest animals are specialists. They have to use some kind of specific resource in a particular way to avoid competition. If everybody in the forest wants to eat figs, then it's a basic brawl, fight to the death. So things evolve to eat different things, live in different sections so that they can all be in the same area. Because of all the species diversity, they have to find various ways to capture their prey and avoid predators. Whether it's insects that have camouflage that make them look like the plant, or some ways to avoid predators, monkeys being able to jump from tree to quickly get away and avoid staying off of the ground so things can't get to them. Now also we have a lot of threats to the rainforest, and unfortunately every minute of every day about 150 acres of tropical rainforest get cleared for logging operations, agricultural, and oil exploration. That's 150 acres every minute of every day. That is a lot of deforestation going on, and a lot of this is not sustainable. We're not doing anything to replant the trees. We're not doing anything to reclaim this area, and the rainforests just keep shrinking. We also have a lot of exotic pet trade going on. People go in, we're going to take the parrots out, we're going to take the monkeys out, and we're going to sell them out into the great big wide world, because there's a demand for these products. As long as you and I are buying it, they're going to take them out of the rainforest and try and make a profit from it. So this habitat destruction occurs basically when land by any organism gets destroyed or altered. We turn it into farmland. Well, we virtually destroyed the ecosystem. A lot of the animals can't live on a farm when we've gotten rid of the trees, etc. So if the habitat that any organism depends on is destroyed, well, obviously that organism is also at risk of disappearing. We're just seeing lots of this happening in the rainforest. There's an estimated 50 million native people that live in the tropical rainforest. This is what they've called their home from time immemorial, if you will. And they are also threatened by the habitat destruction. They use the rainforest for their livelihood. This is where they hunt and they get their food. They do it in a much more sustainable way, but as we go and we cut down and cut into the rainforest, there's a lot of people that require it for their actually livelihood. It's their home. So since they get almost everything from the forest, the loss of their habitat may have to force them to move, to leave, to go into the cities, and this very drastic change of lifestyle actually winds up having them lose their culture that they had. Their various culture and traditions as they move into the cities, a lot of times these things just kind of go out by the wayside. So the tropical rainforest, massive amounts of diversity, various layers, everything that we find in it, but they're in very serious danger. And it's something that we have to pay attention to and try and set up laws, rules, and treaties, and things just you and I have to try and change, because our livelihood actually affects a lot of times things like the rainforest. Well guys, that wraps it up for section A. I'm gonna go ahead and push on with the forest, move into section 2B, but we'll pick up here on another day. But here we go. All right. Section 2B is going to be the temperate forest biomes and the taiga. Here is your essential question. What are some adaptations or adaptations that organisms develop to survive the drastic temperature changes? Remember, in a temperate forest, it is below 0 in the wintertime and up to, above 25, even 30 degrees in the summertime. Drastic changes in temperature, so how have they adapted to these drastic changes? The first one we're going to talk about is the temperate rainforest. We're just coming out of talking about the tropical rainforest. This is the temperate rainforest. So it's in the area between 30 and 60, but it gets lots of rain. Enough rain that it becomes a rainforest, but it still has spring, summer, winter, fall. What's characterized by the temperate is they have your classic seasons. They have cool, humid weather, lots of rainfall, and the tree branches here tend to be draped a lot of times with things like moss, lichens, and lots of ferns all over the forest floor. We only find these in a few places. In North America, they're up in our Pacific Northwest. So kind of the Washington state of America and on up into Canada, British Columbia, this area up in here, temperate rainforest. We also find some in areas of Australia, not all over, just one specific area, and New Zealand. So it's very limited. So we expect to find them only up in this Pacific Northwest and then over kind of in the Pacific South with Australia and New Zealand. Very few and rare that we find them. Although most of the other rainforest of the Pacific Northwest still gets these moderate temperatures. So it's north, but it's still a rainforest, moderate temperatures, etc. Rarely freezes there though. A lot of that area we think of as having freezing cold temperatures, but not in the temperate rainforest. They're right against the ocean, so the ocean currents temperate the weather, and they keep it a little bit more moderate. It still gets colder, but once again, it rarely freezes. It occurs, but not often. The Pacific Ocean keeping it there, blowing this cooler, milder weather. So as these ocean winds, however, meet the coastal Olympic mountains, it produces rainfall. So it's coming in, it's cooler moisture, but as it begins to go up the mountains, it condenses and we get our rain. So this is what tends to give our Pacific Northwest the rainfall. We can see from the picture here, this is what's known as a spirit bear. It's kind of unusual because it's a bit of an albino grizzly. It's a real picture, real bear, but we find this up in this Pacific Northwest. Notice all the ferns, the heavy moss on the plants, etc. Very deep, lush green, but much cooler than the tropical rainforest. Temperate deciduous forest, moving from the temperate rainforest into temperate deciduous. The word deciduous means fall down. The leaves fall down. So this is the big characterization, if you will. They shed their leaves. Now this is going to be between 30 and 50 degrees latitude, basically the United States. Just above Florida, we kind of get the main part of the United States, that's right at 30, and we end around 50. So if you think the United States, you're exactly in the temperate region. Now the range of temperatures here can be extreme. Temperatures can get up to 35 in the summer. Now for a lot of you here in the United States, we're talking like upwards of 100 degrees. And they can also go way down below zero, freezing in the winter. Very vast differences that organisms have to adapt to. These forests tend to get somewhere between 75 to 125 centimeters of water, a little more than a meter to a meter and a quarter of water a year. And all this water helps to decompose the dead organic matter. And unlike the rainforest, the deciduous forests have very rich soil, excellent soil for growing plants, etc. It tends to be deep and rich with nutrients. Once again, looking at our graph or chart up here, we see that we find these things above the 30 parallel, basically between about 30 and 50. Think the top of the United States. Now, if you notice in Europe, it's a little higher up because the ocean currents are carrying the warmer air over, so we find the deciduous forests a little farther north than we do in North America, because the ocean current's keeping it warm here, the ocean currents carry on around there, and it's a little higher up. Notice the rainfall compared to the tropical rainforest, much less. And we kind of get this, the way they have it is summer months are right in the middle. So the winter and fall tends to be drier, more rain in the spring and summer, drying off again. Just classic patterns that we tend to see with, once again, deciduous forests. Now, plants of the deciduous forests. These things, once again, grow in layers. Now, if you're here with me in class in Gainesville, we're used to the deciduous forest. It's what's right outside the door in our classroom, right where we did our site surveys, right up against the deciduous forest. So now we have layers. We have stuff down on the ground, shorter trees, taller, etc. So tall trees such as birch, these tend to dominate the canopy, and then shrubs are down all over the understory. Now here we don't have as much birch in Gainesville. We have a lot more in the way of live oak, laurel oaks. We find hickory. We do find other various types of oak. Sweet gum, very common here. Lots of different types. Once again, those are our tall trees. We have smaller, and then shrubs down on the bottom. Now, temperate forest plants tend to be adapted to survive these seasonal changes. Once again, in the fall and winter, the leaves tend to shed. The seeds go dormant, and they kind of sit under the soil. So all the leaf litter comes down, protects the seeds underneath it. They go dormant during the cold winter months. And then when the spring comes around and the soil begins to warm up and the sun comes in and the leaves have decayed and the seeds begin to sprout. The animals of the deciduous forest are also adapted to the forest. They need the forest both for food and for shelter. They're climbing up in the trees, hiding it, burrowing under. Once again, we find things on the forest floor in the deciduous because the soil is so much deeper and richer. We find things such as mammals and insects, though, they reduce their activity tremendously during the winter. Kind of the farther north you get, the more dormant things become, where some even hibernate, just basically sleep through the whole thing. But a lot of mammals and insects, they kind of have this instinct, if you will, that their activity cuts way down to almost nothing till it begins to warm up again. Now, in a lot of cases, you have animals that can't survive the harsh winter, so they migrate. They just leave. Birds are classic for this. We have the Canadian geese make their way down. Now here around Gainesville, we get the sandhill cranes. The sandhill cranes migrate and move north and south with the weather. They're looking for warmer weather and food. They simply can't handle the extreme cold, and some animals simply deal with it by migrating or leaving. If my wife had a choice and it got cold, she would leave. But that's why we moved to Florida, so we don't have to deal with it. Taking us to the taiga. No, not a tiger, taiga. These are our northern coniferous forests. Regions of evergreen forest tends to be just below the Arctic and the subarctic tundra regions. Very long winters and very little vegetation. There's the pine trees, the coniferous cone-bearing plants. But up here in the taiga, it's very cold, and the growing season can be as little as 50 days, less than 2 months long, where all the growth happens. So they're dormant most of the year, the warm season comes, the snow melts, and they grow for only about 50 days. Very short growing season. So it takes a long time for taiga plants to get very big. It's these pines. Now pines tend to grow really fast, but in the taiga, very short growing season, so it takes a long time for them to be able to grow and get to full size and maturity. So when we look at these pictures up in the taiga, these massive coniferous, well, they've been there for hundreds, and if not sometimes thousands of years. Now, animals of the taiga. In reality, there's a lot of lakes and swamps up here that in the spring and the summer, when they do melt, many things come up there. So the insects all go dormant, but then spring and summer, the snow melts. We have these lakes and swamp areas. The insects come out like crazy, and birds and animals come and flock in for this kind of brief period of time. So they're there, but most things migrate. Very harsh winters, so the birds and a lot of things migrate, deer, etc. They kind of come up eating the nice new growth, but when it starts to get cold, they migrate back down again. Things are migrating typically for food, but they're just leaving because it's not there. Now, the year-round residents, such as shrews or lemmings and a lot of insects as well, they burrow. They just go down under the ground. And once again, they kind of go into a dormant phase. They may store up some food that they eat during the winter, but they're not very active. A lot of things also adapt by having two different color tones. The snowshoe hare. In the summer, they have brown fur. It allows them to blend in with their environment. But in the harsh winter, they shed the brown fur and they grow an extra layer of very white fur, and they blend in with the snow. So we get animals that have these very different adaptations. Some just leave, some have two different coats of fur and different colors of fur to allow them to blend in when it is needed. So we get up into the taiga, and when we talk about grasslands, we'll talk about tundra. The taiga tends to be just below the subarctic, or in the subarctic, below the true Arctic, where we'll talk about tundra in another lesson. That wraps it up, guys, for the forest. See me next time when we talk about grasslands, whether it's tropical or temperate. And we get into the tundras as well. Take care. We'll see you next time.